So I hope you're convinced with the Nebular Hypothesis that we can definitely end up with something that looks like this in terms of an early solar system forming. And so what is this? Well, we have sort of some helium and hydrogen far away. We have some rocky materials close, and of course we have the sun and the solar wind all going. So what I'd like to sort of tell you then is a few things about this formation of planets. Okay, so where would that come from, sort of in this big mix? Where would these clumps come from? Well, I'm going to show you a series of videos here, and the first one is going to be how is it that a couple that rocks could stick together. This is something that I personally sort of always have trouble reconciling, but as I sort of mentioned, I think a few times in this video series now, as a rock goes this way and a rock goes this way, they will collide with each other and maybe do a little rubbing, of course, and when they start to rub like that, they get warm, and so I'll maybe draw these edges as becoming sort of warm like that. And so we had this description a couple times now in terms of ignition of the sun, formation of the moon, and I'm bringing it up again now for formation of the planets, that for some reason here rocks can collide and heat up. And it's just sort of a mysterious process to me. But let me show you this first video here. And what happens in this first video here is it's a short clip, but the person has a piece of wood. And all they do then with this piece of wood is they come in and they hit the wood with a hammer. Okay? And so watch what happens.
Measurement. If light is made up of wavelengths of photons, what is heat? For millennia, this question remained a mystery. But its nature can best be seen using a heat-sensitive camera.
So if I take this piece of wood and hit it with a hammer, then the infrared camera is picking up a change in temperature. It's getting hotter. So the mechanical energy of the hammer is causing an increase in heat.
To understand what is happening in the wood, I've come to meet heat.
So I hope you saw in that video that the place where the hammer came in here and hit the wood, sort of maybe put bam, like right there, then when the hammer was removed, a little glow was left there. Now what the glow is, of course, that's leftover heat. And that's part of our argument here that we mentioned a long time ago about the physics that might go into the Nebular Hypothesis, which is the conservation of energy. So what happened in this case here is the moving hammer, in other words, the energy in that moving hammer got morphed into heat in the wood. Okay, so hopefully you saw that now with the glowing. The moving hammer, the blammo of the hammer got transferred into heat in the wood. And that's exactly sort of where these little red spots are going to come from now. So the claim is that if you have two rocks that are passing by each other here, let's say, here's like rock 1 here, and here's rock 2 here, and this rock is sort of going this way, and this rock is going this way. When they rub each other, you'll get some heat on the edges there where they rub. And so in this case here, it isn't the hammer, but it's the kinetic energy of the rocks themselves that gets converted into the heat. Okay, and so that is the conservation of energy in this process. And so hopefully the hammer hitting the wood sort of convinces you of that. Okay, so the next thing that I personally always have trouble with then is if you have two rocks like this, and okay, they're getting a bit warm here, how do they stick? Well, take a look at this video, which sort of gives you an idea of what lava, which is really what melting or hot rocks are, kind of behaves as.
Look at that.
Oh! I'm gonna do it.
Okay then, and so on the very last bit here, convincing you of how these planetoids might form, we then imagine that we have just tons and tons of rocks moving all over the place. They've all sort of maybe become sticky lava by their, again, the kinetic energy of their motion getting converted into heat via conservation of energy when they collide. And so if this kept happening over and over again, I suppose then it's possible that maybe this rock right here could run in, collide, and then stick with that rock like that until they become sort of a larger rock. And then, of course, larger rocks, as I think I've mentioned then, can then attract other rocks by the force of gravity. They are also hot and sticky like the lava, and they could come together. So watch this final video here, which sort of shows you how a bunch of these rocks could slowly start coming together to form a planet.
The collision nearly destroyed the Earth, spraying molten rock out into space. Most of this rock fell back onto our shattered planet. The rest of the rock stayed in orbit. The force of gravity kept it from escaping out into space. As these jagged rocks revolved around Earth, gravity drew them towards one another. They began to collide, fusing together into larger chunks. Within weeks, these chunks combined with others, growing bigger and bigger. And in less than a month, incredible as it may seem, our moon was formed. That's right.
Okay, and there you have it. So I will conclude then with this idea then, the sun, the heavier materials, rock materials, the lighter ones out here, and the last issue then is how do these little planets start to form into planetoids in these regions here. I'll draw them in green, but hopefully you're convinced between the conservation of energy, the stickiness of rocks, gravity, and then pulling together that they can start clumping up and forming the planets as we know it then. So in the next video, I'll show you some professional graphics about how some of this stuff might have looked, but that's about it for the nebular hypothesis then.